All right, here in this video, I'm going to look at some examples from 4.3 on page 221. And this is problem number 20. And it says that we have an urn that contains 5 red balls and 3 black balls. Urn 2 contains 3 red balls and 1 black ball. And urn number 3 contains 4 red balls and 2 black balls. If an urn is selected at random and a ball is drawn, find the probability it will be red. So we're looking at randomly selecting an urn, and we want to then know what's the probability it's going to be red. So that means we need to look at what is the probability of urn 1 and it is red, or the probability of urn 2 in red, or the probability of urn 3 and that it is red. So that means here the probability of urn 1 in red, well, the probability of urn 1, since there's 3, that would simply be 1/3 times then the probability that it's red. Urn 1 up here contains a total of 8, so the total would be out of 8, and 5 are red, so that would be 5 out of 8. And once again, because it's and, we're going to multiply. Then it's or, so we're going to add the probability of urn number 2. Well, once again, there's 3, so the probability there again is going to be 1/3 if we randomly select one of these urns. And then the probability that we draw a red ball, again here there's 3 and 1, so there's a total of 4, and 3 of them are red, so that means 3/4. Or the probability of urn 3, which again there's 3, so that's 1 out of 3. And so we're going to multiply. There's a total of 6. And then red, there's 4, so that would be 4 out of 6. So then at this point, all we have to do is look at all of the calculations, multiply and add together, and I believe we should end up with 49 out of 72. All right, the next example I want to look at is number 26. Number 26 says that at the Avalonia Country Club, 73% of the members play bridge and swim. So 73%, the probability that they play bridge and swim is 0.73. And 82% play bridge only. And if we select a member at random, what is the probability that the member swims given that the member plays bridge? So what's the probability of swimming given that they play bridge? Now remember, the formula for this is we need to look at what's the probability of swim and bridge, and keep in mind this notation I use out, this is going to be and. So if you see this symbol, this is and this way would be or, and of course our line here means given. So what's the probability of swim and bridge divided by the probability that they play bridge? Well, they tell us swim and bridge is 0.73. And then the probability that they play bridge only is 0.82. So then if we divide 0.73 divided by 0.82, that is equal to 0.89. All right, example number 30. Here we have a gift basket store has the following pre-made gift baskets containing the following combinations already in stock. So here's the table, and you'll notice I added in the total for coffee, the total for tea, and then the total for cookies, mugs, and candy. So the first question is, what is the probability of coffee or candy? So here we're looking at probability of coffee or candy. So that means we're going to look at what is the probability of coffee, or means we're going to add the probability of candy. And then if they share something in common, then we need to subtract away what is the probability of coffee and candy. So if we look here, the probability of coffee, if we go across here, we have coffee, there's 20, 13, and 10, so the total here would be 43, and that's out of a total of 77, plus the probability of candy. And if we look at the candy, the total here would be the probability of candy would be 22 out of 77. And then what's the probability of coffee and candy? So is it possible that we have a gift basket that has coffee and candy at the same time? And the question is certainly yes. Up here, if we go across the coffee, we see here that there's a total of 10 that contain coffee and candy. So that would be 10 out of 77. So if we total this all up, we would end up with a total of 0.714. Okay, for part B, we want to know what is the probability of tea given mugs. So if we look up here, we need to figure out what's the probability of tea given mugs. So the easiest way to calculate this would be is what is the probability of tea and mugs over the probability of mugs. Well, the probability of tea and mugs, what's that going to be? Well, we look up here and we have tea and mugs where they intersect. Up here, that's a total of 10. So that would be 10 out of a total of 77. And the probability of mugs, well, if we look at the column here with mugs, that would be 23 out of a total of 77. So then if we take this, we would have 10 out of 77, and we could certainly multiply by the reciprocal, so that would be 77 over 23. So we end up with 0.435. Okay, so that's the probability of tea given that we have mugs as well. And also with this one, you could have just simply looked at the chart. If you notice here, for example, we have 10 out of 23. Well, what's the probability of tea given mugs? Well, you could simply say, well, we know that we're talking about mugs, so that means we're looking here. And then if we think, okay, there's a total of 23 mugs, then what's the probability of tea knowing that there are mugs? Well, if we're only looking at this column, then that tells us there's 10 out of a total of 23 if we're given that we are selecting mugs, then there's a chance of 10 out of 23 that we would have the probability of tea. All right, the last one says, what's the probability of tea and cookies? This would be 12 that we have in common for your tea and cookies here would be the 12 out of the total of 77. So that's 12 out of 77. So you would end up with 0.156. All right, number 36. It says that we have a department store. There are 120 customers and 90 that buy at least one item. If 5 customers are selected at random, one by one, find the probability that all will buy at least one item. So we have 120 customers. 90 of those buy at least one item. We're going to select 5 customers at random, and we want to calculate the probability that all that we select, all 5 of these, will buy at least one item. So the question is, first of all, what's the probability then? We know that 90 of the 120, and we're looking at selecting 5. So again, if we think of it this way, if we're looking at 5 of them, 1, 2, 3, 4, 5, what's the probability that the first person we select buys at least one item? Well, there's a total of 120 customers. And 90 will buy at least one item, so that means that would be a chance of 90 out of 120. So after we select that person, that means now there's only 119 customers left. And if that first person did buy the one item, which that's what we're looking at, all 5 buy at least one item, that means now there's only 89. And then again, now we've selected 2, so we're down to 118. And then that means there's only 88 left that bought at least one item. And then it continues to 117. So there's 87 left. And then there's 116 until there's 86 left that bought at least one item. So then all we have to do now is multiply these together, and you would end up with a probability of 0.231. All right, the next example is number 38. And it says here, the American Automobile Association reports that of the fatal car and truck accidents, 54% are caused by car driver error. And if 3 accidents are chosen at random, find the probability that all are caused by car driver error. Okay, so that means we're looking at those that are caused by car driver error, and they tell us that 54% are caused by car driver error, and we're going to select 3. So if we select 3, that means what's the probability of the first person? The first accident being caused by a car driver error? That would certainly be the 54% or 0.54. And because that has no effect on the next accident that we choose, it's going to also have 54% chance. And same for the third. Okay, so one event does not affect the other. So here all we have to do is multiply these together, or simply take 0.54 raised to the third power. And if we do so, you should end up with a probability of 0.157. Okay, part B says, what's the probability that none are caused by the car driver error? Well, if it's 54% accidents are caused by car driver error, then that means we could take 1 minus the 0.54, and that means we'd be left with 0.46. So once again, that means we would have the 3, and none of them are caused by the car driver error, so that means we're looking up here at everything else, so that would be a 46% chance. So that would be 0.46 times 0.46 times 0.46. And if we multiply that out, we would end up with 0.097. And part C, it says, what's the probability at least one is caused by car driver error? Okay, now this is example. Typically when we see this at least, we may think that we are going to have to use the complement. And the easiest way to look at this would be looking at 1 minus the probability of the complement of at least 1. So at least 1 means the probability of none. So that means we would look at 1 minus the probability of none, and the probability of none is exactly what we just looked at up here in part B as the 0.097. So we could simply subtract 0.097 and we get a probability of 0.903. So in other words, that's going to be a very high probability. Okay, number 54. Here we look at types of vehicles. It says the Bargain Auto Mall has the following cars and trucks in stock. We have foreign and domestic, and then we break that down into SUV, compact, and midsize. And I've inserted the total here. And the question is, are the events of compact, so here's our compact, and domestic independent? And keep in mind, when we say the events are independent, that means that the probability of one has no effect on the other. So to be independent, that means the probability of compact given domestic should be equal to the probability of compact. Because what this is telling us, this says that given that we have selected domestic here, it has no effect on the probability of a compact car. So if we look at this example, what is the probability of a compact given that it is domestic? Well, that means we need to look at what's the probability of compact and domestic divided by the probability of domestic. So the probability of compact and domestic, well, compact is here in the center, and then domestic, so that means compact and domestic here we have a total of 100 out of the total vehicles would be 300, and we're going to divide that by the probability of domestic. Well, the total domestic cars would be 210, and that again is out of 300. And if we simplify this, we would end up with 10 out of 21. Okay, so that's looking at the probability of compact and domestic. So now if we look at just the probability of compact, what does that equal? Well, how many compact cars do we have? There's a total of 150 out of 300. So 150 out of 300, that would simplify to 1/2. So we need to compare the probability of compact and domestic, which was, the probability of compact given domestic. Does that equal the probability of a compact car? Well, the probability of a compact we said is 1/2. Is that going to be equal to the probability of compact given domestic, which was 10 out of 21? And because these are not equal, then that means they are not independent. So if you think about this, that means that the probability of a compact, given that it is domestic, does have an effect on this probability of compact. If it doesn't, then that means these two probabilities would have to be equal, and therefore they would be independent. Because they're not equal, that means there is some effect on this being domestic does affect the probability of being compact.